Okay, a quick little instructional video for today's project. Shouldn't take a ton of time for you to accomplish, really, but I like it. It just takes everything we've learned about forces. We've learned a lot about forces and different types of forces, and um, we want to organize it all into one chart here. So this video is going to show us what I want to have happen with this forces chart little mini project here. So here's a picture I snapped of today's assignment, the forces chart. You can see it's a chart that organizes everything we know about forces. So I'm just going to do like a quick little example of what I'm looking for here. So you fill in the equation. So we'll just do the top line together here. So equation for net force is F net, and I'm sorry, it's small, very hard to write this small. F net equals M A, Newton's second law there. Wow, that should be an A. It looks kind of like a Q. Let's try one more time to get an A. Then that's better. So F net equals MA, that's our equation. Solving techniques or strategies can be anything you've picked up on that's helpful, such as a free body diagram. I'm just going to shorten it FBD for short because I'm not writing all this with a mouse. But you guys kind of get the point there. So give me an equation for it and some problem solving techniques. And then what causes this force? In this case, right, for net force, it's just all the other forces, wow, sorry, all the other forces added together. I'm just going to put a plus sign there. I'm tired of writing with this mouse already. But all the other forces added together is what causes the net force. So we just did the top line together. Please do notice I'd like complete sentences because you're not writing with a mouse. You're writing with a keyboard or a pencil or something a lot easier to write with than this mouse here. So complete sentences, please. One complete sentence is fine. For the X and Y directions, I'm looking for, like, X direction is usually cosine, so you can say F net times cosine or F net times sine or cosine, right? And then if you want to be more complete, and then solving techniques is like SOHCAHTOA, looking for opposite, adjacent, hypotenuse, all the trigonometry stuff. So that's what I'm looking for the X and the Y directions. These ones here is I'm looking for your trigonometry skills. So there should be a sine or cosine in these boxes here. Make sure you get your sines and cosines in there. And then this last one here, contact and field force. This right here, what do I mean by that? So contact means that in order for that force to occur, two things must be touching, such as a push or a pull. In order to push or pull something, those two objects must be touching each other. If I'm going to push or pull my lawnmower, I need to touch the lawnmower. So several of these forces we've listed here, several of these forces are forces where the two objects, in order to have a force, um, those two objects actually need to be touching each other. And then there are a few, I should say, where they do not need to touch each other, such as gravity, right? The moon and the earth impart gravity onto each other, right? They both feel each other's gravity, but they're not touching each other. Same with like the sun and the earth. So gravity is what we call a field force. It sends out a force field, and it does not actually need to touch an object in order to do the force. Same thing with, well, I don't want to give it all away, but there's another force we learned about that doesn't actually need to touch objects in order to have the force. And notice there's two different kinds of gravity. So let me make that be my last note here. Got two different kinds of gravity. We've got if G is known and universal gravitation. So universal gravitation is what we just learned with the capital G, G, M, all of that stuff. With like the asteroid extra credit practice. That's the one with the equation, the big fancy equation we've just learned. G known, what I mean by that is like you're on a planet where you know gravity. Like Earth, G is 9.8. So the equation for that one would just be mass times gravity, just like we're used to, right? What's the strength of gravity on Earth? How do you find that force? Is just mg. So there's your equation for gravity. Um, I'll even write it in here. I'm making this way too easy, but that's okay. Mg is our equation if we know gravity. But if we don't know the acceleration of gravity, if we don't know g, if we just have like, here's a planet and it has this mass, and here's a moon and it has this mass, and here's the distance between them, and we need to calculate that gravity, we have a much more complicated equation that goes into this box here to solve for that. So that's why there's two different gravities. One is like we've been doing for most of the semester, where we know what g is, like 9.8 for Earth, for example. The other equation is the one we just learned last week for gravity. That works all the time, even if you don't know g. So get that done. You can print it out, do it on paper. You can make one on paper. So if computers aren't your thing, you can just make a chart like this on paper and send me a picture. I will also make the Microsoft Excel file available to you in the assignment on Teams. So if you just want to fill it in with electronically right into the document, you can do that as well. So get this to me by tomorrow. Tomorrow morning would be great, so we can move on. And notice it does say legal notes at the top. So no, and it's kind of hard to enforce. I don't know how our quizzes are going to look going forward. But if I ask you to only use, your legal notes like usual for the quiz, this would count for legal notes, whatever that's worth these days. Get this done today and let me know if you have any questions. Thanks.